Hello, hello, and welcome to the review for the first part of our KC4 test. All right, for number 1 and 2, we're going to calculate the average rate of change using graphs. So what we do is we look at the 2 points that I have marked for you. Once it allows me to draw, there we go. So this is the point on the left, this is the point on the right. I am going to count if I'm going up, down from left to right, and how many to the right. Okay, so from left to right, it looks like I'm going down 1, 2, down 2, to the right 1. So our average rate of change is -2/1. Same thing for number 2. This is the point on the left, this is the point on the right. This time, it looks like I'm going up from left to right. Let's count. 1, 2, 3, up 3, and then 1, 2, 3, to the right 3. And this one, I will reduce to 1/1. So if you can reduce it, do reduce it. Number 3 and 4 ask us to calculate the average rate of change from the following table. So that means we need to use the following formula, the change in y's over the change in x's. All right, so the change in y's is y2 minus y1, and the change in x's is x2 minus x1. All right, let's figure out what that is. All right, this is y1, that's y2, x1, x2. Notice that the 1's and 2's are together. All right, let's do this. y2 is 24, y1 is 0, so the top is 24 minus 20. Did I say 0? I feel like I said 0. y2 is 24, y1 is 20. x2 is 0, and x1 is -1. So on the bottom, we're doing 0 minus -1. Let's see what we get. 24 minus 20 is 4. 0 minus -1 is 1. So our average rate of change is 4/1. Let's do the same thing for number 4. So it's the change in y's over the change in x's. y2 minus y1 over x2 minus x1. You know my obsession with the color coding. Let's label x1, x2, y1, y2. All right, so on the top we have 15 minus 13. And on the bottom, we've got -4 minus -2. All right. 15 minus 13 gives us +2. -4 minus -2 gives us -2. And I can simplify this to 1/-1. All right. Onwards we go. Yes, a plant is currently 30 inches tall and grows 6 inches per week. Let's model this scenario with an arithmetic sequence in explicit form. So arithmetic sequence in explicit form is as follows. AN equals A1 plus DN minus 1. A1 is our starting. So that's 30. It's our first term, our starting growth. D is the average, is the pattern, the common difference. Growing 6 inches means +6 and -1. Letter B asks us to rewrite that form into function notation. So I'm going to start off by taking this explicit form, and instead of AN, I'm going to have f of x. 30 stays 30, plus 6 stays +6, and the n turns into an x. Now the next step is to distribute, and I distribute the number that's next to the parentheses, which means 30 stays 30. All right, let's do this. 6 times x is 6x. 6 times -1 is -6. I'm almost done. All I have left to do is combine some like terms, and I see 2 like terms, regular 30 and regular -6. So that means 6x stays all by itself, and 30 minus 6 is 24. So my function notation, whoops, f of x equals 6x plus 24. For letter C, how tall will the plant be in 4 weeks? We take that function notation, we plug in a 4 instead of x. So instead of 6 times x, I have 6 times 4. 6 times 4 is 24, and 24 plus 24 is 48 inches. Let's do the same thing for number 6. A plant is currently 4 inches tall and grows 2 inches per week. Let's model the scenario with an explicit form of the arithmetic sequence. Here is our formula. A1 is our starting growth, our first term, so 4 inches. D is our common difference, our pattern, grows 2 inches, so plus 2. And n minus 1 stays as it is. Let's rewrite the explicit form of the sequence using function notation. So instead of an, I'm going to have f of x. 4 stays 4, and plus 2 stays plus 2. But n minus 1 becomes x minus 1. What we're going to do next is distribute. Once again, we can only distribute something that's next to the parentheses. So 4 stays 4. 2 times x is 2x. And 2 times negative 1 is negative 2. Our last step is to combine like terms. It looks like there's no other x's here other than the 2x. But we do have 2 terms that can be combined, the 4 and the minus 2. 4 minus 2 gives us 2. So function notation, f of x equals 2x plus 2. How tall will the plant be in 10 weeks? We're going to take that 10 and plug it in instead of x. Because 2x is 2 times x, this time we're going to be doing 2 times 10. 2 times 10 is 20, and 20 plus 2 is 22 inches. Okay. So that is the first part of what we learned for this test. The next part that we learned has to do with graphing. So let's do that. Okay. All right. First things first, let's graph f of x equals 1/2 x plus 3. Now, remember, we have y equals mx plus b. M is our slope, b is our y-intercept. So in this case, our slope is 1/2, which means we go up 1 to the right 2. Our y-intercept is 3, which means we start at 0, 3. So I'm going to put a dot at 0, 3. And then I'm going to go up 1 to the right 2. I'll do that a couple times. For my own sake, I'm just going to try to make the straightest line I can on technology. You do only need 2 points to create a perfect line. Right? I went up 1 to the right 2. Did I go up 1 to the right 2? Uh-oh, something got messed up. Let's try that again. Maybe my line got messed up. I'm going to just go ahead and zoom in on the graph. Maybe it will help me be more accurate. So I start at 0, 3. And then I go up 1 to the right 2. Oh, no, I did graph it right. I think I drew the line wrong. Okay, so 2 points. You use your beautiful straight edge to create that line. All right, number 2. Same idea. We have a slope of -3, so that's -3/1. And our y-intercept is 7, so that's 0, 7. Which means I start right here at 0, 7. My slope is -3/1. I'm going to zoom in to make it more accurate. So that means, uh-oh. What did Gumin do? Did Gumin zoom in too far? Of course, Gumin zoomed in too far. That's okay. Look at that. Oh, that looks so pretty. Okay. So, I'm not going to zoom in any further than this. I'm sorry. So, we're going to go down 3. 1, 2, 3, over 1. There's our second point. If you want to draw more points to make it more accurate, you absolutely can. I think I did that on my paper version. But here, 2 points are sufficient to draw a line. It never turns out straight on technology. I don't know why. But here is our beautiful f of x equals negative 3x plus 7. All right. Number 3 asks us, given the function 2x minus 3, let's graph that transformation. So we have our line already graphed. Plus 4 means up 4. So I have 3 points for you. Let's go up 4 on each of those 3 points. Ready? Let's go. 1, 2, 3, 4. I'm going to make it blue. New point. And then up 1, 2, 3, 4. New point. And then one more time. Up 1, 2, 3, and 4. There's our dot. And of course, you use a straight edge to create a wonderful transformed function. Make sure you have arrows on both ends. That's very important. All right, number 4. So I will admit that I accidentally graphed this one wrong. I graphed this one as a plus 7. Ha ha ha. Whoopsie doopsie. But you know what? The most important part is this minus 10. This minus 10 means down 10. So let's go ahead and move all 3 points that I have graphed for you down 10. And then we will have our transformed line, even though I graphed it wrong in the first place. Okay, let's do this. Down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. New dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. New dot. And one more for good measure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dot. Of course, you use a straight edge. I'm just gonna try my best there. Okay, pretend that's a beautiful straight line. Of course, on my answer key in person and on Teams, it looks so nice. It looks so nice. Okay, number 5. Given the function f of x equals negative 4x plus 6, graph this transformation. All right, so transformation tells us to multiply by negative 1. So I'm going to take every single one of my y coordinates and multiply by negative 1. 10 times negative 1 is negative 10. 6 times negative 1 is negative 6. 2 times negative 1 is negative 2. And negative 2 times negative 1 is positive 2. All right, let's graph it. Okay, negative 1, negative 10 is right here. 0, negative 6 is there. 1, negative 2 is there. And 2, 2 is there. Of course, draw a perfectly straight line using a straight edge. Mine isn't beautiful, but hey, I guess you can say I tried, but I'm going to try one more time because I don't like that it didn't go through all the points. I'm going to just, you know what? That's as close as it's getting, so I'm just not going to be picky about it. It'll look much nicer if not done on a screen, okay? One more. Given this function, here it is, transform it by dilating it by 2. All right, so we're going to multiply every single number in the y column by 2. Negative 6 times 2 is negative 12. Negative 4 times 2 is negative 8. Negative 1 times 2 is negative 2. And 4 times 2 is 4. Let's graph. Negative 2, negative 12. It's somewhere down here. This one doesn't really fit. That was an oopsie for me. 0, negative 8 is right there. 2, negative 2 is right here. And 4, 4 is right there. So, of course, you're going to use a beautiful straight edge to connect them. Oh, that's so ugly. I'm going to try that again. Okay, you know what? We tried. I can never make these straight lines straight. See how beautiful they are by hand? That's because I used my idea as a straight edge. So let's just pretend that it looks as beautiful as my answer key does in person and on Teams. But there it is. You'll have a straight edge, so yours will look much nicer than this. If you have any questions, please make sure to ask me. Otherwise, have a wonderful rest of your day. Bye!